this next lesson of GDScript about multiplying, if I'm not mistaken. Let's see. Continua. Select lesson. I'm here in lesson 14 about multiplying. Okay, continua. Quizzes completed are 2. On 2? Alright. Our robot health is always between 0 and 100, but as our robot fights, we want to increase strength and toughness. When a character levels up, it might deal more damage to enemies, gain new abilities, or in our case, gain more health. We define a level variable to keep track of the level of the robot. It starts at level 1. Alright, level 1 is the default, the starting point, as written in the code text editor. Var in red level equals 1. The function level up is level equals level plus 1. And since the level equal 1, it's 1 plus 1, so it's 2. But, as we briefly saw in that last lesson, a robot could have a range of variables that could increase when it levels up. Alright. Variable health, 100. Okay, these are the statistics, probably. This one is the default. This one, the health. This one is the maximum amount of health. The variable power is probably how, when you hit, what kind of damage it gives. And the variable defense is, well, defense. In this lesson, we'll focus on increasing the robot max health. The variable max health, is the maximum amount the robot health can be. We change our heal function to use this variable. Alright. We could add 5 to the max health every time the robot levels up, but it's an addition, isn't it? So it's better to. That will increase max health the same amount every time. For example, if you graph max health, it will look something like this, probably a linear one, not exponential. The growth is linear, so in our case, we want to feel a feeling of more and more power as the robot levels up. Oh, hello, Sonar Bloom. Thank you. Thank you so much. I hope I can study properly and register what I'm reading. I think I did a refreshing of the previous lessons, but still, thank you so much. I'll try to study. And have a good day, afternoon, morning, evening, and a good week. No, wait, it's still Tuesday, isn't it? In some countries at least. Or even Wednesday. Man, it's already Wednesday. Never mind. But yeah, the growth is exponential if we want to make a feeling of more and more power as the robot levels up. We want a graph like this. Show me. Okay, exponential. With each level, more maximum health is added than the previous level up. To get the exponential growth, we multiply the maximum health by an amount greater than 1 each time the robot levels up. To multiply values together, we use the asterisk. Okay, where is it in the keyboard? Oh, it's near the enter keyboard, right above the plus. Okay. What is the value of damage? 5 per 3. Won't calculate damage. Damage, variable damage equals power per level 15. Okay. What is the value of damage now? Okay, power per level. And when the damage per 2. Okay. If the variable is damage and the power per level is multiplied, and then we multiply again the variable damage per 2 equal damage per 2, it's 30. Okay. Alright. Let's level up our robot and add exponential growth to maximum health. Alright. Okay, I'm reading and trying to memorize it. In the practices, you increase the robot maximum health and add a special ability to our robot to make it extra tough at high levels. Alright. We want our robot to increase in strength as it levels up. Let's increase its health exponentially. Alright, let's go. Variable level equal 1. That's the level. If I want to variable, okay, add to the level up function, so it does the following: increases the level by 1 and increases maximum health by 10%. Okay. Okay. I think I can do this. Level plus equal 1, and then max health in exponentially. Okay, the asterisk is above the plus button and equal. Aspetta. Okay, 10%, like this. Maybe I'm not good at modulo. I probably made a mistake. Is it? Max health should be 121 after level up 1. Oh shit. Oh, alright. Okay. How do I do this? Should I do the modulo here like this? No, it's not possible. Yeah, right. How do I actually 121? Alright, let's look at the hint. Oh, I need to multiply by 1.1 floating. Alright. I didn't take that in account. Oh, hello, hello. What the hell? What the hell? Welcome. Nice to see you. That emote made me jump scare, but in a funny way. Finally caught your live stream, Angel. Why, thank you. I'm glad that you're... Wait, are you supposed to be awake at these hours? No, yeah, you probably are. It's afternoon now, or evening, I forgot. But yes, thank you for checking me out. I'm not sure if I should name you aloud since your username is like this, but nice. Thank you for checking me out, really. Oh yeah, wait. Reducing damage at higher levels. When our robot level is 3 or more, we want it to take a lot less damage. Okay. Added to take damage so that the following happens. If the robot level is greater than 2, reduce the damage amount by... Okay. I think I can do this probably. If half... Okay, if the robot is level greater than 2... Okay. The robot is level 3. Attack for daily damage should reduce to 5. Oh, this is too much math. Alright. No, wait. Yeah, tab. If level... No, cavolo! Level is greater. 2? Yeah? Okay. Take the mage. Okay. Maximum health? If health is like this, if level is greater than 2, reduce the damage amount. Take damage. Okay. Wait a minute, let me think. If the robot level is greater than 2, reduce the damage amount, health amount, okay. Amount, amount, no, wait. Damage, okay, wait a minute. Take damage, reduce, okay, amount, and amount is multiply uguale 0,5 maybe? Something like this? I'm not sure. Okay, damage amount is correct value. The character did not take half damage despite being level 3. Did you multiply the amount by 0.5 to reduce it? Yeah, I did it, but then why? Okay. Damage amount is correct value because it's not. Okay, maybe I need to apply to this above. Run? Why? What is the mistake? You need to check if the if statement at the top of the function to check the robot level is greater than 2. Top of the function. Oh, to listen, multiply by a value as 1. Yeah, I did it all right. You need to check the an if statement at the top of the function. At the top of the function, yes. To check the robot is level if level 2 is greater than 2, amount is okay. What the hell? Okay. Okay. If level is 3 or more, we want it to take a lot less damage. It's going to reduce the amount by 3. The robot is level 3. Okay, an enemy is going to attack for 10 damage. 10 damage, okay. The damage should reduce to 5. Okay. Did you multiply the amount by 0 to reduce it? Yes, I did. What the hell did I wrong? Check, run, solution? What the hell? If level amount... Oh, I placed it the wrong place. Can you see that? Like this. Okay, this is my mistake. I should have placed a match at the very top and then placed the half minus equal amount later. Alright. Interesting. I think I get it. It's because it reads the computer, the CPU, or whatever it makes the loop function as it is making the... Alright, it's making the instruction come first here. No, cut. Tab. And then go here. Man. So this is it. Okay. Continue. It's important to place the correct order of the instruction. Alright. Suppose we want to increase the size of the robot when it levels up. As you may recall, we do this by using the following code. Okay, scale. Oh, it's becoming larger, bigger. Okay, as we talk in lesson 7, the scale variable has 2 sub-variables to it, x and y. This is because scale... Oh, if it is my favorite thought experiment demon. Why, thank you, Mr. Mugen. Welcome. I'm surprised that people remember me finally as a demon. I'm so happy. But at the same time, I really need to do more fight experiments. But otherwise, welcome. Nice to see you at these hours again. But yeah, this is because scale is a vector too, which stands for two-dimensional vector. A vector represents 2D coordinates. Oh, but speaking of something, I was reading the first chapter on Manga Dex, or should had no, eh, the manga you told me about the last time about a girl who wants to do car jumping, space jumping with without a car license, and meeting this girl who is quite bubbly. And I actually like how they share the same mindset, but they are in space. But yeah, enjoy the new hour is a pleasant surprise if I can make it. Why, thank you. You're such a silver-tongued cat, hyping hope. But thank you, really. Oh yeah, the car camping, it's really nice. Yeah, right. It's really cute and yashike. Oh wait, let me check a bit. What are vectors? A vector in physics. Yeah, it's like jumping as a vector. No, sorta. But yeah. What are vectors? A vector in physics is a quantity, something you can measure with a magnitude and a direction. For example, a force applied to some object, the velocity, speed, and direction of character, and so on. Okay, this is kinda bad for me. I try to remember what it meant in the real world physics. We often represent this quantity with an arrow, yeah? In Godot? Oh yeah, can I ask some of you if you're still present here? If the audio works well, or is it different from the last time? But yeah, let's see. Oh, wait. Studio? Study? Let's see. Studio. Okay. There we go. Oh no. Wait, I made a mistake. Freaking hell. Okay. Hear you loud and clear, Agent Angel. Why, thank you so much. Oh, Mr. Time Traveling Cat Hope. Okay. Let's see if I can do this properly. In Godot, 2D vectors are a common value type named vector2. Unlike plain numbers, we store two decimal numbers, one for the x coordinate and one for the y coordinate. Alright. We often represent magnitude and direction. Okay. On the x coordinate and y coordinate. Okay, so far you come across two variables in the course which are vectors. Which are they? Okay. I think it's speed, no, position. No, wait, and position is just position, the location without movement. So it's probably speed and scale. No, wait, never mind. Wait, I remember. Yeah, no, cannot be. Really? Ah, I see. So we're about variables and values. Vectors are great for games. Vectors are essential in video games since they allow you to represent a character's movement, speed, and direction. Oh, if you like a girl less too, I wonder if you also try Shumatsutori. It's similar but with a motorcycle instead of a tank. Oh, I'm gonna try that. Nowadays I'm trying to read. What was the? Wait, it was Princess Tutu, Utena, the one that is the revolutionary girl. Something like about fables and with a aesthetic was shoujo. Something like girl power. But otherwise, yeah, I'm going to try Shumatsutori then. I was also trying this anime that I think Riri spoke about, Apocalypse, Apocalypse Tour Hotel, and so on. Oh, those are classic? Alright. The Utena and Princess Tutu, is it? I actually didn't watch them that much in the past, so I'm trying to catch up to reality and what is actually considered good. Princess Tutu and Utena are very love serious. Oh, really? Yeah, I guess so. Depends, because I never saw them aired on the broadcast of the Star Stream here in the Romance language country. But otherwise, I'm glad to hear that. Guess I'm on the right track. But yeah, Shumatsu Turin. I write this down. Let's see. In Kolevai. If their love series, it definitely spoke to the people who watched them. I wonder why, but I guess it was the zeitgeist of the time, or something that someone needed to hear at the time, of course. Hello. Oh, hello. Welcome, Roberto. Ciao, Roberto. Is the audio sounds kind of weird to you, or is it normal as usual? I asked this to Mr. Mugen as well, but I want to hear it from you as well, if it's actually strange, since I changed again my audio settings. But otherwise, hello. We were talking about the vectors, no, wait. We were speaking about camping and then about the motorcycle traveling as well with Shumatsu touring, and also other stuff like what's the name of these 2D vectors? The 2D vectors. Take this turtle AI here below. It's following my mouse. Alright, my cursor. The code is a bit too difficult for now, so we'll spare you the details. But this turtle gives you a glimpse of what 2D vectors can do for you and for your game projects. Alright. We scale the robot again, this time adding it directly using a vector 2. The following code has the same effect as the previous example. Oh, alright. Scale plus equal vector 0.2, 0.2. Utena was very unique and groundbreaking when it came out, so it is very influential to this day. I hope you enjoy it. Oh yeah, I did. But it's something that actually makes me wonder. What is the episode? I actually never always forget the names, but the girl with the yellow rose, I think so, was having an egg, laying an egg, and I was thinking what it meant. So far, I thought that the egg meant something like, oh, since the school is named after the Phoenix Authority School, I think so at least, like the concept of the phoenix that rebirths. I was thinking the egg might mean something like, oh, this is a child of hers, but she's laying as a metaphor of an egg. However, the egg breaks and she forgets every time, as they live in an eternal loop. Apparently so. But I'm not sure what it means. I mean, I have my own pet theories, but I'm not sure how to formulate it well. But otherwise, I wonder if the egg is like a metaphor of the devouring mother, and the egg is like a son that when he gets his egg broken from the, what was the name of the other guy that actually comes back with the cracked egg? Never mind. It's a good works when it makes you think like that, I think. Yeah, right. It's like full of, does it mean more than it does? Or is it just my mind that is tricking me? Audio feedback might be easier next time, but it sounds fine. Alright. Sounds it could be better, but I'll try next time indeed. After all, I'm not sure either what is different from the... No, wait, I actually know what is different. But it's better to continue on this Godot thing, at least. Notice how we use parentheses and two arguments inside the parentheses, just like other functions call. We call this a constructor function call. You can think of it as a special kind of function that creates a particular type of value. The code vector 0.2 constructs a new vector 2 value with its x value set to 0.2 and its y value set to 0.2 respectively again. Using vectors to change the position. We can add and subtract vectors to the position because it is a nice. Because it's a vector. If we wanted to move our robot to a new relative position, we will add a vector to its position. Oh, alright. How would you move the robot 50 pixels to the left? I think it's like this. No, you don't need that probably. Yeah, vector position minus equal vector 2 parentheses 50 comma 0 parenthesis closed subtracts 50 to the subvariable x and 0 to y. Position dot x minus equal vector 2 50 comma 0 tries to subtract that to the vector to the subvariable x, which is a decimal number. The value types are incompatible. If you try to do this, you will get an error. Okay, increase scale using vectors. Okay. Add a line to the code to the level up function to increase the scale of the robot by vector 2. 0.2, 0.2. Every time it levels up. Okay. Level up function to increase the scale. Okay. Let's create the function then. Func level up. Oh shit. I don't think it will make any mistake, but alright. Okay, function to increase the scale of the robot. Okay, function level up. Okay, it's already here. It's a double. Function, add a line. Okay, increase the scale. Scale. Okay. Okay. Correct scale after 2 levels. Okay, scale. Scale uguale vector 2 0.2 0.2, and then we do this plus something like this, I guess. Okay, there we go. Oh shit, it's so... No, so never mind. Oh, num. It's so zoomed out now. Resetting the size and position using vectors. The robot level has increased a lot and so has its size. Whereas fixes by resetting the robot scale and value, no, scale and position values. Create a function named reset robot that set the scale and position of the robot. Okay. Func reset robot, and then we make... Okay, the scale needs to be 1.0. Okay, scale equal... No, wait, it's not equal. No, becomes... No, equals... No, wait. Okay, scale vector 2 1.0 1.0, and then position uguale vector okay, vector 2 0.0 to actually reset the position. Is it like this? It's probably wrong. Why is it still like this? Oh well. You've seen what you can find the function. No, you've seen that you can use function to reuse code. In this lesson, you learn about loops. Loops help you repeat code. To illustrate how loops work, let's take a game board split into a grid. A robot can move to neighboring cells by changing a vector to variable named cell. Oh, cell! Sorry, I was thinking of Dragon Ball. But yeah, never mind. It represents the current cell the robot is in. When we increase cell X, the robot moves to the right. Note that it delayed the robot movement in the app to help you visualize how it moves. Okay? Oh, nice. It moves across the arena. The following code will normally move the robot instantly. Okay. We can move diagonally by adding vector 2 directly. Cell plus equal vector 2 1 1. Cell plus equal vector 2 1 1. Alright, like twice. The bow code works for a predefined board with a size of vector 2. Okay. But the move to end function wouldn't work if the size of the board was different. Okay, understand. To implement a general solution for all board size, you can repeat the robot's movement until it gets to the end. For code that repeats, we can use loops. Okay. Using while loops to repeat code. You can use a while loop to make the computer repeat a block of code until you meet a specific condition or decide to break from the loop. Here's how we use a while loop. Variables number equal 0. While numbers is less than 4, print number plus equal... Oh, okay. Until the number is 4, you need to print the number and add the 1 until it reaches 4, probably. Okay. We use the variable number to keep track of how many loops the while loop completes. Each time we go through the while loop, we add one number. Okay. Oh, alright. Okay, this is the debugger. Okay. Okay. Let's apply this to our move to end function. This time, we compare the number of loops to the board width. We go through the loop until we reach the width of the board. Note that we move the robot until its position is one less than the board width because we are counting tiles from 0. Okay. A board of 3 by 3 cells will have cell coordinates going from 0 to 2 on both the x and y axis. Alright, like this maybe. Oh, interesting. Move to end. While cell point dot x is less than board size x min 1, then cell x plus 1. Okay. I'm trying to understand. Wait a minute. What number is minus than... Okay, let's try again. While loops can cause issues if you're not careful. Your while loop can run infinitely. In that case, the application will freeze. Take a look at this example. If the variable number is set as default as 0, and while the number is minus than 10, draw a square. But what will happen if the computer tries to run the code above? Wouldn't it be like this? Oh shit, is it like this? You're right, because we don't increment number within the while loop. It always stays at 0. Oh, it needs to be actually explicitly told that is draw square plus 1, maybe? As a result, the number is always lower than 10, so we never break out of the loop. Since there is no way to exit the while loop, the computer will attempt to draw squares infinitely. Okay. Okay. We program it often to an infinite loop. Okay. When programs stop responding on your computer, it's often due to an infinite loop. When to use while loops? At first, you will not need while loops often. Even the code we show here has more efficient alternative. Also, there is a safer kind of loop, for loops, which we'll look at in the next lesson. Yet, while loops have important intermediate to advanced level uses, so you at least need to know they exist and how to use them. We use while loops every time we need to loop an unknown number of times. For example, games run in a loop will typically generate 60 images per second until the user closes the game. Oh, that is possible thanks to while loops. There are good... there are other good uses for while loops. Oh, adding while to end strings so we can loop our lovely company forever. You're quite the... how can I say? You have so many good lines. I shall learn from you as the ultimate cheerleader sort of deal. Yay! But yeah, reading and processing a file, like, thank you so much, Mr. Mugen. But yeah, I'm not sure how to respond properly, but at the same time, I hope I can properly become a tutelary spirit somehow. But yeah, I'm kinda embarrassed. Still, thank you. Reading and processing a file, like a text document, line by line. Processing a constant stream of data, like someone recording audio with a microphone. Reading code, oh, interesting. Writing code and converting into an instruction the computer understands. Okay. Reading code. Various intermediate to advanced level algorithms, like finding paths around a map for AI. Let's practice some while loops as they are useful to know. It's also an excellent opportunity to practice 2D vectors. Then we'll move on to the safer for loops in the following lesson. Okay. Our robot has this. The goal is this. Our robot has decided to stand at the top of the board. Complete the move to bottom function so the robot moves to the bottom of the board. Okay, let's write it down. One day, and you will build a resistance to a line like this. Yeah, I hope so, because I cannot get mocked all this time by such an actually really nice pickup line. But jokes aside, well, not really. I'm actually serious. But yeah, let's see. Let me focus on these. The board size is determined by the vector2 variable named board side. The robot starting cell is vector 2.0. Make sure to use the while loop so that the loop functions works for any board size. Okay, while the board size. Okay, I guess I need to remember how it's written. I need to remember back. While board size. No, wait. Complete the move so the bottom moves to the top bottom. Okay. While board size is okay. I think I remember. Let's try it now. It's greater than the starting cell. No, wait. Board size cell. No, wait. Board size. No, wait. I need to remember back. Conferma. I need to read it back. Why board? It's actually in there. Right. Man, alright. I think I understand it. Sorta. Practice. Okay. While cell is minus than board size. Board size. Ok. Mentre intanto che la cella è minore della taglia, della grandezza della... Ok. Like this. Why cell? Okay, how many cell is this? Uno. Why cell 0.0 and board size is how many of them are that? 1, 2, 3, 4, 5. 5. Is it like this? I don't get it. I need to just try it out. Andrew is cute. Chat happy equals true. Okay, this is too good of a pickup line as a programmer. Are you perhaps very well versed on it, or are you just picking it up much faster than me on programming. If so, you're actually too much of a genius. Ah, I'm getting lost. I'm getting lost. But thank you. Let's see. Let me see. Okay. If the wild cell is minor, then cell needs to be. No. No, wait. No, wait. No, wait. No, wait. Copy? Let's see what happens if I happen. What happens if I have. No, okay. Practice expected. Okay, yeah. Yeah, just as expected. So. No, wait. How can I do that? So. Okay. So. 0. 1 to 0. This is kind of complicated. Più 5. This is complicated. Oh, the metal cell is declared the color size. Oh, okay. While cell is minus cell plus. No, the metal board size is declaring the current size. Oh, alright. I not get it. I feel so lost. Okay. Oh no. Open Lawson. Okay. One number. Oh, okay. Board size. Cell X. Oh, okay. It's cell and variable. Okay. Okay. The cell X. While cell Y. Ah, man, I feel a loss. Oh, if I make the uplifting message on topic, it will at least contribute to the lesson. You are making it much better than me, to be honest, but you don't know how happy it makes me. Why, thank you. You're really cheering me up a lot. It's actually having an effect on the whole session stream. Let's see, so plus Y. Board size. Punto E. What? What is it that I need to write? Oh yeah. So, if you. No, wait. So. So. You. Cinque? Except an indented block after a while. Alright. How do I do this? Let me see. I have to alter. Yeah, I know this. Oh, yeah, I do this. Oh, use while cell. -1, maybe. Oh, is it? No, wait, I didn't make it correct either. Let's see, confirm. It's probably here again. Ah, right. So plus y plus equal 5. Alright. And then. Okay. Cut. So. Okay. So. Punto y. Oh, isn't a rot. Did you increase the cell? Robot gets get the board. Oh, maybe it's okay. Pew equal 5. Alright. No, yeah, alright. Is it 4? Okay, I remember. It was something about the 0 is considered a number 2 or a spot. So it will be 0, 1, 2, 3, 4 as 5 slots in total considered. Alright, introduction to for loops. In the last lesson, we looked at while loops. We found they were useful if we don't know how many times we should repeat the code. But while loops can result in infinite loops if we are not careful. For example, the loop below never ends because we can never increment the number. Variable number equals 0. Is 0. While number is lesser than 3, the solve increments vector to 1, 1. Okay. It goes so diagonally until the number is 3, I guess. But a safer is a kind of loop. The for loop. We look at it in this lesson. Unlike while loops, for loops don't run forever, so you are much less likely to get infinite loops back in your game. We recommend using for loops instead of while loops because of this. For numbers in range 3, sol plus equal. No, sol is sol adding vector the direction of 1 x and 1 y. Okay. For number in range. Interesting, huh? Okay. Here we can never increment the number. An increment, what the? Increment is the amount by which a value changes in your code. Okay. The range, parentheses, function. Godot has a helper function called range. Oh, alright. Calling range with n as the number in the parameter or the parentheses creates a list of numbers from 0 to n minus 1. So calling range 3 outputs the list number 0, 1, 2 and range 5 as outputs. 0, 1, 2, 3, 4. Oh, it probably range as before with the print range by considering 0 also a number in the 6th slots. Okay. For how for loops work? In for in a for loop. Why? Thank you. All right, I'll stretch and drink. Why? Thank you. Thank you. All right. Thank you so much, Mr. Mugen. I stretch and drink. Oh no, wait. I stretch too. Let me see. Me. Okay, I can do this. Thank you so much. Good reminder. Alright. You sound pretty tired today? Alright. Well, more like I'm feeling at peace of mind. At the same time, however, my throat is a bit sore from eating too much pizza, probably. Like, my vessel has her parents buying a pizza each week, but at the same time, it's only eating the the crust. It feels like bread sometimes. I need to drink more water, maybe. Okay. So yeah. If you're yawning because your legs had a nice meal, then I'm more happy than worried. Thank you, thank you. Thank you for worrying about me in the first place. I appreciate it a lot. Alright. But yeah, I'm mostly yawning because I should be asleep. I should be asleep. But I want to finish this at least for one-fourth, half, fifth, fourth, something like that. One-fourth of the whole game lessons. So yeah, how for loops work. In a for loop, the computer takes each value inside a list, stores in a temporary variable, and executes the code in the loop once per value. Okay. Nice. For number in range 3, print number. In the above example, for each item in the list 0, 1, 2, Godot sets number to the item, then executes the code in the for loop. We'll explain erase more thoroughly. Vai, forza, forza, ce la puoi fare. Grazie mille, Mr. Mugen. Signor Mugen. mm. Alright. Sets number to the item. Yeah? In range sets item to the number. Okay, in range. Okay. Print number 2. Okay. Okay, I think I get it. We will explain arrays more thoroughly in the next lesson, but notice that number is just a temporary variable. You create it here when defining the loop, and the loop takes care of changing its value. Also, you can name this variable anything you want. The code behaves the same as the previous example. Okay. In both examples, print the variable we created. Number in the first example and element in the second. Number in the first example, okay. Number in the first example, and also here, okay. We can break down the instruction the loop runs, and you can see how a loop is a shortcut to the code that otherwise gets very long. Oh, alright. The variable array 0, 1, 2, and the variable element. Since the element equals array 0, print element. Okay. When element is equal to array 1, print element. Okay. Okay, element 2. Okay. We can put whatever code we like in the loop's code block, including other function calls like draw rectangle. Here's our move. Here's our old move to end function, which used a while loop. Function move to end while cell dot x, while the x-axis of the cell is lesser than the board size slots of x minus 1, open a new tab indentation, then create a cell x on the x-axis plus 1 slot every time. Okay. Why the cell x is lesser than the board x size minus 1? Okay, I think I understand. It needs to be minus 1, alright. If we use a loop instead, because the minus 1, the minus 1 also accounts for the array numbers with the 0 counted in as an other digit. of the whole, like, what's the name? No, never mind, I can find it. But I think I get it now. Like, if the range is 6, then it counts 0 instead of going already from 1 to 6. But since there is also 0 as counted, it goes to 0, 1, 2, 3, 4, 5, and those are 6 digits. Alright, I think I get it now. Why the while loop has the -1 for now. So if we use instead a for loop, the code becomes a little simpler. For number in range both size -1, so x plus its equals is so x plus 1. Okay. I think I get it, sorta. With the for loop, we check the board with first. When we move the robot that many times, this is simpler than checking if the robot reached the end of the board over and over. The function still works the same way. You can move it below. Okay. No. No, cavoli. Never mind. Using a for loop to move to the end of the board. Okay, I can do this probably. For cell in range. Okay. Board size y. So okay. Board size cell y. If okay. So y. No, is it? So if y plus equal. No wait, I need to remember this one. -1 is quante? 5. Probably. Oh wait, never mind. Okay. So yeah. In range? Is it not like this? What am I doing as a mistake? Yeah, I know that. Yeah, I know that. In range, is it not what I did that? Error in expect after identifier? What does it mean in an identify? Explain. You get this error when the name between the for and in is not a variable name, or I'm missing the in keyword. Oh, maybe I think I get it. You can get, okay. Oh, okay. Lucille, okay, vector 2. Oh, I think I get it. It's vector 2. Oh, vector 2. Man, I'm forgetting to typo. Why? Okay. Invalid operand types int. Okay. Oh, I see. For example, we can directly add a whole number to the text string. If the computer talks about an invalid operand, then they assume that the operation doesn't exist for the type you're trying to use. For example, you can add it to the 2D vector, but you can add a whole number of text to a 2D vector. Oh, I see. Okay, I'm getting confused. Good. Let me see. Confirm. So x plus 1. Okay, I think I did it correctly then. But then, what happened? So punto y, and then 2 base int. I can get indexes on base int. Vector, okay. I just need to check the hint, damn it. Okay, to loop enough times. Yeah, alright. You can get the index y on base int. Okay, it doesn't exist. Okay. The cell is like this. 2.0. No, cavoli. No? No. Okay. Like this, maybe? No. So? Let me see. What is the wrong thing? Is that it? So? No, never mind. This is bad. This is bad. Let me go back and redo it again. Practice. Okay. I understand how to do the for loop. For number in range. Okay. In range board size size epsilon minus 1, and then colon, and then there is, what was it again? So I'm trying to remember. What was it again? It's like this. Oh man. Plus equal vector 2 virgola 3 2 5. Ok. Oh, right. I forget always the vector 2. Oh, shit. The robot isn't at the bottom of the game board. It increases cell if y coordinate. Seems I did a mistake, but where? Oh, I need to just do it like this? Oh, I need to just add one here. Okay, I think I get it now. That was understandable. I hope I can remember it next time. Like this. Reset. For loop. No. For the number. We need to loop for the number of times. If it's lesser than, no, if it's in range. In range board size y minus 1. No, never mind. Okay. Cell is cell plus vector 2 0 plus add one cell in the y-axis. Okay, I can do this. Just because I needed to read the answer. Alright, continue. Use a for loop to remove the duplicate code in a run function. Okay. I think I get it 3 times. Alright, 4 numbers in range. We all need new knowledge of for loops. We can condense the code, take up less space, and make it easier to modify. Draw 3 squares. Shapes are 100 pixels apart. Squares are all 100 by 100 and use for loop. Okay. Jump, draw rectangle, and void range. Okay. In range. In range 3 maybe? Okay. I'm not sure. Hello! Welcome, Stefan Brooker. Nice to see you today as well. Tonight? Today? As well. But yeah, I'm trying to figure out how to do this all, but it's kind of complicated right now. So, duplicate code. Hints. Yeah, I read it. But otherwise, for numbers, jump. No, I should delete this all maybe. No, Caval, I did it correctly. Is it this? Seriously? Oh, it just this. Oh, my intuition worked. Alright. Creating arrays. How much is missing again? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Continuiamo fino al lesson 20. But yeah, welcome. The range function we saw in the previous lesson outputs a list of numbers. For example, calling range 3 produces the list of numbers 0, 1, 2. Okay, run. Alright. A list of values, numbers, or otherwise has a precise name in code. We call it an array. Okay, this is a list. So we can say calling the range function produces an array of numbers. We can directly write and use that array inside our for loops instead of a range function. Okay. Alright. As you can see, the code still works the same. Notice that you can create a for loop. We also create a local variable to which the loop assigns one value, like the element here. You can name it anything you want, however, before you write after the for loop. Okay. Per iteration. Okay. Above, we name it number because the array we loop over contains the three numbers, but we could name it anything we like elements. In free, the array free, and print element. Okay. If we unwrap the for loop above, we get the following code with the exact same behavior. Okay. 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 How do I write an array? We write arrays with this way in GDScript. Value underscore 1 comma space value underscore 2 comma and then etc etc. You start with an opening square brackets, then you write comma separated values that compose the array. Finally, you need a closing square brackets to complete the array. Alright. Let's see. No, sorry. Oh, wait. I hope you are taking care of yourself. It's getting cold in some countries, but also really hot at the same time. It's kind of like a mess. I hope you are also drinking water, Mr. Mugen, and everyone here as well. Remember to stretch as well, and do lots of what's the name? Self-care as well. Oh shit. Alright. Here are a couple of valid arrays. Oh no, wait, when you write, no wait, you start with, to write the syntax arrays, you start with an opening square brackets. When you write comma separated values, they compose the array. Finally, you need a closing square bracket to complete the array. Here are a couple of valid arrays. Notice how you can mix values and how they don't need to follow one another. Oh, interesting. You can mix the values and they don't need to follow one another either. It's easy to forget those things when you don't have tiny voices in your head reminding you, yeah, right. You're a voice in my head, just like a sunlight that is a speck of light as you close your eyes and see glitters within the membrane of your mind. Something like that. Because arrays themselves are a value type, just like numbers of vector 2, we can assign arrays to variable to reassessment later. That will come in handy in the next lesson, where we use those variables in loops. Okay. But first, let's see when you use an array. Okay, when you use array in computer programming, they use arrays all the time. Precisely, you use them whenever you need to store a list of things. Oh, you always need a list of things in games. The player's part in an RPG. As a limit cap, the items in the player's inventory, the high score in an arcade game, the object in the game world. Okay, it all was and many more relying on arrays. Using arrays to follow a path. Let's look at the widespread use of arrays in game, finding and following a path. In games, you need allies, or monsters to find their way to the target, whether it's the player or some point of interest. To achieve that, we use pathfinding algorithms. As the name suggests, those algorithms find the array between 2 points and allow AI to traverse the game. Many of the algorithms use arrays of vector 2 coordinates to represent the path. Take this turtle pet. It wants to follow the robot, but there are rocks in the way. How can we tell it where to walk to reach the robot with an array? Okay. Oh, like it's associated one number coordinate to each slot. I see, I understand. Sorta. Okay, I think I get it. Walk into the robot. Help the turtle find its way to the robot. Give it a path to follow to reach the robot. Okay, let's try this. The turtle wants to meet the robot, but it cannot find its way on its own. Okay. 1.0. No, wait. 0.1. Like this, maybe? 2.1. 3.1. This one I get it a bit under easily. No, wait. Ok, 5. 5.1. 5.1. No, cavoli. 5.1. Ok. 5.2. Okay, let's try this. Oh, wait, why? Oh, okay. Vector 2, right. We come separated value quickly. Okay. No, it's probably not. Ah, cazzo! Okay. No, cavoli. From what I understand, it's like this. Is it like this? Dove? Oh, okay, like this. I'm so slow. Ok. Oh, qui non c'è. Is it? Okay. It should be 1 unit again. Copy. Is it really like this? I feel like it's so... No, solution. Oh, seriously, it's really like this. Oh my goodness. But the formatting is better than expected in the solution. Okay. Oh, all right. 5.3. There we go. All right, well done. Man, that was... Oh my goodness. Need to call... Alright, in this tactical game, the player and the computer can select multiple units at once. You need to call the select unit function and pass it an array of vector 2 coordinates to know which units are selected. Okay. Select units. Okay. Select units. Okay. Okay. It's 0... No, 1, 0 for the first unit. And then 0.3. 4, 2? No, cavoli. Oh, thank you. Oh shit. No, never mind. Ah. 5, 1. Let's try this. Oh, expected. Oh, alright. Eh? Oh, right. I forgot this. Okay, this one is understandable to me. Looping over arrays. We use the range function combination with for loops, of course, because the range function produced an array, but the for keyword could loop over. We can give for loop any array, and we will loop over them just for the same. Okay. Oh, interesting. For each element inside the array, the for loop extracts it, stores in the temporary variable number, name and number, temporary variable name and number, and executes the loop's code once. Inside the loop, you can access the number variable, which changes on each iteration. So, since it changes on each iteration, the code works regardless of the array where you store it. Often, you will store arrays in variables for easy access. Okay. Alright. So, instead of writing numbers with one single s, you have number. You actually write numbers and store the variable value in another variable. No, wait. I think I understand. In range, the range becomes the name of the variables of an array, like this. Oh, I see. Variable numbers. So, instead of writing in a range and then write the parentheses inside, you write the range as the variable numbers equals 0, 1, 2, for example, as an array already. Okay, what will this code print? Probably 1, 2. Oh shit. Alright. Compared to the previous example, we start the array in the numbers variable. Using the numbers variable in for loops allows the computer to access the arrays of numbers like before. We have 3 numbers in the array, 0, 1, and 2. Okay. Okay, in the previous lesson, you made a turtle walk along a path by writing vector 2 coordinates in an array. It's a for loop that makes the turtle walk along the path. Okay. Okay, func move path. For cell in path, the turtle moved to cell. The turtle moved to cell. Okay. Oh, for each coordinate in an array name and select the units, we check if there is a unit in that cell. You saw we selected. In that case, we use an array, a loop, and a condition together. The variable units is an array, and the variable selected units is also an array that is still empty, but we need to search where it is in the first place. So we write a function to select the units in the cells. For cell in cells range, if cell in units, oh, this is complicated. If the cell in units selected, append the cell, update. Oh, this is complicated. The code above uses several features you haven't learned yet. In a condition, the in keyword allows you to check if a value exists in an array. Oh, this is important. This is really important. The array's append function appends a new value at the end of the array. Oh, alright, since we wrote here but the variable units are empty and also the selected units are empty in the arrays, it's like append makes a cell get inside here the arrays. Alright. When a function exists only on a specific value type, you write a dot after the value to call the function in it. Like the x and y in the position, maybe. Okay, we'll revisit these two features again in the following lessons. The beauty of loops is that they work regardless of the size of your arrays. The code just works whether you have 1 or 10,000 units to select. It's all accomplished with only a couple of lines of code. That's the power of computer programming. Okay. Move the robot along the path. Okay. Or AI path finding algorithm provided a path for the robot to move to the right edge of the grid. Alright, it needs to follow the slots cells along the blue thread line. So, to move the robot, call its move to function. Alright, move to function. Oh, robot. Is it like this? Did you call Romo? Yeah, it did. Sorta. Okay. Hints. What am I supposed to do? Oh, okay, for loop. Okay. Hints. For loop. Need to pass the cell position. Okay. For. No. For. 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 What's the name? For cell in robot path I think I did a mistake. Yeah, I did, but what's the problem? Yeah, for cell in robot path, robot move. Oh, cell. I forgot the cell part. Oh shit. Alright, I always forget the parameters. For cell in robot path. Okay. We want to draw many rectangles, something surprisingly common in games. However, writing this code by hand can get tedious. Instead, you could store the size of your shapes in arrays and use a loop to draw them all in batches. Okay, 4. Numbers in rectangle sizes. And then draw rectangle numbers. Okay. Okay. This is cute until the day arrives when Angel rules the land with an arbitrary robot and an iron fist. Oh yes, something like that. Alright. Oh no, I made a mistake. Okay. Oh, I need to... Oh, alright. Okay. Jump. Two few arguments. Drawing loops. But yeah. I don't think I can actually do that yet. I need to actually go out from the RAM labyrinth of your CPU at first and not be blocked by being a virtual being for the time. But yeah, that's a good reasoning. You're too smart. Alright. Alright. Draw land. Draw rectangle sizes. Numbers. Maybe. Wait, what is the solution really? I'm feeling bad. Ah, it's size X. Alright. Man, I feel defeated. Okay, numbers in numbers X numbers people. Huh? What is it? Oh, size X and 0. Okay. Alright, I think I get it, sorta. Okay, I think I get it, sorta. 1, 2, 3, 4, 5, 6, 7, 8. How much did we do? Just 5 lessons. Alright. One last next time for the strings, or maybe twice again on lessons. Alright. Thank you for coming to my stream in the first Sorry, never mind. Thank you all for coming to my stream in the first place. Good work today. Thank you for the pickup lines in the first place, Mr. Mugen. And thank you for checking me out as well. Go to sleep as well. Or have a good day afterwards. Because as for me, I'm going to go to the land of dreams. But this is just a metaphor for me, for the human me to pass out. Alright, thank you all. Sweet dreams. Yeah, have a golden day. Bye bye. Alright, ciao ciao.